Bismillahirrahmanirrahim. This is Rabia Khan, roll number 63, and presentation which is assigned by Dr. Amjad Ali Arain. Presentation topic: Descriptive Statistics. Statistics is concerned with the describing, interpretation, and analyzing of data. It is therefore an essential element in any improvement process. Statistics is often categorized into descriptive and inferential statistics. It uses analytical method which provide the math or model and predict variation. It uses graphical method to help making numbers visible for communication purpose. Why do we need statistics? To find why a process behaves the way it does, to find why it produces defective goods or services, to center our process on target or nominal, to check the accuracy and precision of the process, to prevent problems caused by assignable cause of variation, to reduce variability and improve process capability, to know the truth about the real world. Descriptive statistics. Methods of describing the characteristics of a data set, useful because they allow you to make sense of the data. Helps exploring and making conclusion about the data in order to make the rational decision. Includes calculating things such as the average of the data, its spread, and the shape it produces. For example, we may be concerned about describing the weight of a product in a production line. Next, the time taken to process an application. Descriptive statistics involves describing, summarizing, and organizing the data so it can be easily understood. Graphical displays are often used along with the quantitative measures to enable clarity of communication. A data point that is significantly greater or smaller than other data points in a data set. It is useful when analyzing data to identify outliers. They may affect the calculation of descriptive statistics. Outliers can occur in any given data set and in any distribution. Outliers may indicate an experimental error or incorrect recording of data. They may also occur by chance. It may be normal to have high or low data points. You need to decide whether to exclude them before carrying out your analysis. An outlier should be excluded if it is due to measurement or human error. The example is about the time taken to process a sample of application. Measures of position. Position statistics measures the data central tendency. Central tendency refers to where the data is centered. You may have calculated an average of some kind. Despite the common use of average, there are different statistics by which we can describing the average of data set: mean, median, and mode. Mean, the total of the values divided by the size of the data set. It is the most commonly used statistics of position. It works well when the distribution is systematic and there are no outliers. The mean of a sample is denoted by X bar. Median, the middle value where exactly half of the data values are above it and half and below it. Less widely used. Are useful statistics due to it can reduce the effect of outliers. Often used when the data is non-systematical. Ensure that the values are ordered before calculation. Median calculation. mode, the value that occurs the most often in a data set. It is rarely used as a central tendency measures. It is more useful to distinguish between multimodal distributions when data has more than one peak. Standard deviation. The average distance of the data points from their own mean. A low standard deviation indicates that the data points are clustered around the mean. A large standard deviation indicates that they are widely scattered around the mean. The standard deviation of a sample is denoted by S. The standard deviation of a population is denoted by M. The shape helps identifying which descriptive statistics is more appropriate to use in a given situation. If the data is symmetrical, then we may use the mean or median to measure the central tendency as they are almost equal. If the data is skewed, then the median will be more appropriate to measure the central tendency. Thank you.